Give examples of numbers you know that belong in each number set. Make sure to choose numbers that are not in other sets and that are contained in the sets you're describing. So this describes the types of numbers that we go through. Like for example, is the number 6? Is that a natural number? Is it a whole number? Is it an integer? Is it a rational? Is it an irrational? Is it many of these things? And if so, what is the lowest level that I can describe it at? So when we talk about, let's describe each of these sets. When we talk about the natural numbers can be described as, often these are called the counting numbers. When I start to count, it starts to learn 1, 2, 3, 4, 5, etc. Those are natural numbers. So an example of a natural number might be 5. And when we start talking about the whole numbers are the natural numbers, and also, which I'll write, that's a union symbol, maybe I'll write and 0. So whole number would be 0. I could have written 5 as well, but again, to distinguish it from what's different from the natural numbers, I wrote the thing that makes it different. Now, integers could be described as the natural numbers, 0, and the opposite of the natural numbers. Now, when we talk about the opposite, one way to think of it is physically on a number line. If that's 0, and we start putting natural numbers in here, say this is 6. 6 is the same, 6 is 6 away from 0, and on the opposite side of the number line, 6 away from 0, is negative 6. So the opposite of 6 would be negative 6. So it's on the opposite side. The other way to think of it is it has the opposite sign. So if it's positive, it's negative, and if it's negative, it's positive. So the integer is the natural numbers 0 and the negatives of the natural numbers. So for example, negative 5 would be an integer. Rational numbers. Rational numbers, you see it has the word ratio in it, and it's because it's any integers. It's integers, or I should say, it's a number that can be expressed, and I said can be, it's an important word, as a ratio of two integers. Now you might ask, what's a ratio? A ratio is a comparison of two numbers, often expressed as a fraction. So you could think of this as a number that can be expressed as a fraction of two integers. So examples of that, 1/2, because 1 is an integer and 2 is an integer. Negative 2 over 3, negative 6 on the bottom and 1 on the top. Anything that can be expressed as a ratio of two integers. Other examples, 0.3 barred. Right, that is actually 1 divided by 3, 1/3. And even though it's not expressed as a ratio of two integers, it could be expressed as a ratio of two integers. Another example, 10. Even though it's not expressed as a ratio, I could put it over 1, and that creates it as a ratio of two integers. So rational numbers, anything that can be expressed as a ratio of two integers, doesn't have to be expressed as it to still be considered rational. And so now irrational are numbers that cannot be expressed as a ratio of two integers. For example, square root of 2 We type that in our calculator. The square root of 2, I believe, is 1.4 something. Let's see, 2. I'm going to take the square root of it. 1.4142135623. So you notice there's no repeating going on here. So I can't somehow find a way of converting this to a fraction. So there are other numbers like that. E, pi. These are irrational numbers. And these, both rational and irrational, make up the real number set. Now, of course, there are other numbers out that are not real, like imaginary numbers. You'll often see I. But think of it, the structure here matters, right? So all natural numbers are whole numbers, but all whole numbers are not natural numbers. And all whole numbers are integers, but not all integers are whole numbers. And all integers are rational, but not all rational are integers. And rational and irrational do not intersect at all. They're different things altogether. So hopefully you get the idea here, and we will continue this later.